Welcome to this presentation, and it's around AOS-CX 10.09, the new release, and specifically around the OSPFv2 enhancements. My name is Steve Bartlett. I'm a technical marketing engineer supporting CX switching. This is the agenda. It's in two parts. The first was configurable default metric for OSPFv2 using the default information originate command. That was one of two. And in this presentation, OSPFv2, we're looking at the changes to, or the flexibility with the configuration with administrative distance. So let's dive in on the changes to the administrative distance, AD. In 10.09 release, the administrative distance can be changed for specific OSPF route types. Prior to 10.09, the admin distance could be changed, but for all OSPF route types. So this enhancement provides a lot more flexibility for managing preferred routes with OSPFv2. So first of all, what is administrative distance? The administrative distance is the first criterion that routers use in order to select the best path when there are two or more different routes to the same destination. So the lower the admin distance, the higher the preference, and it is only locally significant. And here in this example, we have switch A receives two routes on two different interfaces from two different routing protocols. So we've got OSPF and RIP, and the default admin distance is different for each routing protocol. OSPF has a default admin distance for 110, and RIP has a default admin distance of 120. So as the OSPF admin distance is lower, the OSPF route will be preferred over the RIP route. So to summarize the step change, prior to 10.9, we could change the admin distance within OSPF, but only for all OSPF route types. So moving forward with release 10.09, we can change the admin distance, but we can also discriminate between the type of OSPF route. So we can discriminate between intra-area routes, inter-area routes, and external OSPF routes. The external OSPF routes will be the external type 5 and 7 routes redistributed into OSPF from another external process. So why is this important? Well, many networks are advertising routes and re-advertising routes from other route processes, and this can cause problems. So let's build a slide and show an example. Let's take an example here. Routes 172.16.233.0 is advertised from Edge Switch 01. It is learnt from RIP, re-advertised into OSPF, and this is an artificial scenario, of course. And subsequently, because it's re-advertised into OSPF, it will have an external route type 5 LSA, a type E2 route, which then will be populated in the OSPF routing table as presented as an E2 type route. So from Edge Switch 1, it's advertised to router core 1. Now note the difference in admin distance for each routed protocol, 110 for OSPF and 120 for RIP. So that's all well and good. So in core 1's RIP table, the switch core 1 RIP table, the OSPF route is preferred as there is an admin distance of 110, which is lower than the RIP admin distance of 120. And this is the route that is entered into the route table. So that's good. That's exactly what we want. So let's have a little bit of a complication now. We have to play the what if game, an artificial scenario, of course, to demonstrate a routing loop. So what if core 2 and core 1 are both EBGP peers as well as OSPF peers, for example, and their routes are redistributed into a dual home network, EBGP network, and this is a very common connectivity model. So for illustration purposes, I'm redistributing OSPF routes into EBGP on core 2, and also on core 2 I'm redistributing EBGP routes back into OSPF. This is purely to generate a routing loop. So now let's check the RIP tables of the core 1 and core 2. So let's have a look. Now on core 1, if we look at the RIP table, there is a change, and it's a significant change because EBGP has an admin distance of 20, and that's now entered in core 1. And that means that that is the preferred path for route 172.16.233.0. It's going to be via eBGP and not OSPF. Likewise, on core 2, it thinks it's actually got a path to network 172.16.233.0 at a interface 131.1/3/1, and that needs to core 1. So what does that mean? Well, it's pretty obvious, really. We are now in a routing loop situation. So core 2 thinks that OSPF route 172.16.233 is via core 1, and core 1 thinks that the same route is via eBGP 172.16.233 via core 2. So what does that mean? That means we've got a routing loop. So how do we change this or correct this? It's very simple. We can change the external distance on the OSPF process, and we can change it to 10, and this is for the external type routes. And what will that mean? That will mean is that then 172.16.233 is now preferred by OSPFv2. In the real world, of course, we would have route filtering on core 2 as well as part of a best practice solution. But for illustration purposes, I'm just using this method. And you can see now, once we've done that, we should have our routing table that route table is clean on core 1. Don't forget the admin distance is only locally significant. So to summarize then, our routing loop now disappears because we've changed the admin distance on core 1 using the distance external command under the router OSPF process, and that will change, and we've changed the admin distance to 10 for external type routes, which means that route 172.16.233.0 is now the preferred route in the RIB on core 1, which means it would be the preferred route placed into the routing table. Of course, this is an artificial example, but you can see how there is much more flexibility with the options of changing admin distances for specific OSPF route types, providing better routing options and flexibility. So don't forget, the admin distance is only locally significant on the local switch routing process, and the change of value is not propagated to other routes as part of the route learning. And of course, different route processes have different administrative distances, where OSPF has 110, RIP, for instance, has 120, and by default, of course, eBGP has an admin distance of 20. So there is just one real caveat in this feature change for administrative distance setting, and that is that if we make an administrative distance configuration change in one OSPF process, it is applied to all the OSPF processes within the same VRF. So do be mindful of that. This concludes this session, and thank you for watching.